All right, switching up a little bit. I'd planned on, after the previous video, jumping into R and Stack Crunch and demonstrating how we make the calculations using statistical software. But I'm regrouping because I was stepping back, looking at the long-term plan for this lesson. And we have a lot. We'll be shifting gears from here's a statistical technique to here's the way that we address the statistical technique using software, and then how we write up the results. We're going to dive into writing research questions, identifying dependent and independent variables. So a lot of important videos coming up. So just decided to restructure things and go through a presentation of a dependent samples t-test. But again, there's going to be a lot in store. This is going to be an extremely important lesson because we're making the transition into some key stuff. So what I want you to think about for a dependent samples t-test is we're looking at the difference, well, as compared to an independent samples t-test, where we look at the difference of two means. The focus in a dependent samples t-test is to look or examine the mean of the differences. So it's no longer about the differences of the mean, it's about the mean of the differences. Now that's probably just making your brain go into some sort of convulsions. Just hang with me and I'll do my best to explain and demonstrate that. All right, so dependent, think about matched pairs. In other words, a dependent samples t-test, we have subjects where two measurements are made on the same subject. An independent samples t-test has one sample, which is independent of the other sample. We create the means for each and we compare them. That's not what we do here. In a dependent samples t-test, we have two measurements. We take the difference of each measurement for each person, patient, case, and then we concentrate on that as our new, essentially our new sample. Still, we are going to look at the hypothesis tests and confidence intervals for this procedure. Sorry, I just got a text from Pastor that crocked me up. So a little bit of notation. So D is going to be the individual difference between two values. And I think this is where things are going to start to make a little bit of sense. So just take your eyes down at the bottom. You'll see that I have 8 participants. And there was a blood pressure 1 taken. So for the first participant, it was 128. And then something, I don't know what scenario you want to visual or imagine, but there was something done, and then there was a blood pressure number 2 taken sometime later. So for this particular participant, it was 122. So you can see that the difference is -6 because the measurement actually decreased -6. Second participant, 142. Next blood pressure measurement was 140, so it decreased by 2. So that is our string of D's, the -6, the -2, the -5, the 2. That last column are the individual differences between the two values. Now, D bar is just the mean of those. So if I take -6 plus a -2 plus a -5 and divide by 8, the mean is -4.5. So that's the D with the bar above it. So it's the mean of the differences. So again, circling back to what I said a while ago, it's not the difference of the means, but it's the mean of the differences. So SD is the standard deviation of the differences. In this case, it's 4.24. And N would be the number of pairs of sample data, which in this case would be 8. The mu sub D would be the population mean for all differences. So instead of just these 8 participants, if we're wanting to look at the difference in the blood pressure medicine 1 and blood pressure medicine 2 for our population, which we can't do because it'd be too many people. So again, we depend on a sample to make that statement. then mu sub d is a notation that stands for that. And again, mu sub d is unknown. We're trying to estimate it. All right, so some assumptions, and we're going to get into assumptions more now that we're moving into more relevant statistical techniques that you may use in nursing, occupational therapy, health sciences, whatever your field. So first thing, the sample data are dependent. In other words, they're matched. We still need a random sample, and we still need that the sample data is either from a normal distribution that's normal, or is a large sample. And typically in we actually talk out of both sides of our mouth. We speak out of both sides of our mouth as statisticians. Large, in this context, typically means greater than or equal to 30. But what we really want is sample size 100 or larger. But sometimes you can't do that. Sometimes, sometimes you have to depend on a sample size of 6 or 8. So. But we'll cross that bridge when we get there. All right, so the process, same thing. State your hypothesis, level of significance 0.05, use technology to calculate the test statistic and p-value, make a decision, and calculate and interpret the 95% confidence interval in the context of the problem. So you can tell that the hypotheses, the null, I didn't do a very good job of copying and pasting. Right there, that should be H sub A, not H sub O. So our null hypothesis is that the mean difference is 0, so there's no difference between the pre-score and the post-score. Again, circling back to blood pressure example, blood pressure 1 and blood pressure 2, so there'd be no difference in those. So the alternative hypothesis, again, should be H sub A, is that the mean of the differences is not equal to 0. Next thing we do is we calculate the test statistic. Don't worry about this too much because technology will take care of this for us. From the test statistic, we will calculate the p-value. Decision, still the same. If we reject, we have statistical significance. We say that the mean difference is not 0. If we fail to reject H sub O, then we do not have statistical significance. And we cannot reject the claim that the mean difference is 0. Confidence interval still focuses on 0. If the mean of the differences is 0, then our confidence interval will contain 0. We do not have statistical significance. If the confidence interval does not contain 0, then we have statistical significance, and we conclude that the mean of the differences is not 0. So if we have just an example, hypothetical, -5 to 10, notice that contains 0. So we conclude that mu sub d is equal to 0. From -18 to -3, notice the entire interval is negative, so we would conclude that the test result is statistically significant and the mean difference, the mean of the differences, is less than 0. And a similar argument for 4, 20. The entire interval is above 0, so we conclude that the mean of the differences is greater than 0, and we have a statistically significant result. All right, that's it. All right, so next video, we will dive into the statistical software packages and see how we make these calculations, and we'll move forward creating research questions, defining independent, dependent variables, and things like that. All right, take care.